When the floods hit Assam, the water arrived with terrifying speed, completely swallowing local infrastructure. Families lost their homes in a matter of minutes. Mothers were forced to cling to their infants in surging rapids just to survive the night. At least 75 people are dead. Hundreds of thousands have been displaced across 7 major districts, and the local agricultural economy is completely shattered. This level of devastation stands in stark contrast to the region's geography. Assam is a state built around the massive Brahmaputra River, and its communities are intimately familiar with heavy seasonal monsoons. Yet authorities are classifying this specific event as an anomaly we haven't seen in 60 years. So if Assam's infrastructure and land are designed to handle routine heavy rainfall, what invisible variables cause the local ecosystem to suddenly snap and unleash this catastrophe? To understand the failure, we have to trace the water back to its source. The catalyst occurred on July 19th in the high-altitude hills of neighboring Nagaland. This data point lays out the scale of a freak weather event. 137 millimeters of rain dropped in an 8-hour window. That intense concentration meant localized areas absorbed up to 500% more rainfall than their normal capacity in a single day. This topographic map visualizes gravity taking over. The massive volume of high-elevation runoff in Nagaland aggressively funneled downward, filling 3 distinct tributaries, the Daiku, the Desang, and the Dhansiri rivers. Those 3 fast-moving tributaries rush toward the Assam plains, attempting to empty into the massive Brahmaputra River. But they hit a wall. The Brahmaputra was already swollen from the rains. Because it was completely full, it blocked the incoming water, forcing a violent reversal. The tributaries spilled backward, quickly overflowing their banks and drowning upper Assam districts like Sivasagar and Charadeo. The sky provided the catalyst, but the land's total inability to route or absorb the overflow points to a deeper, artificial failure. Historically, this region relied on natural shock absorbers. Dense hill forests and deep riverbeds worked together to slow down and contain monsoon runoff. But aggressive, unchecked deforestation has stripped those hillsides bare. Without deep root systems acting as a sponge to hold the soil and retain water, the land's absorption capacity drops to near zero. A heavy rain immediately turns into a violent surface runoff. Down in the valleys, unregulated sand mining and heavy excavation machinery have severely damaged the waterways. Tearing apart the riverbanks weakens their structural integrity. This triggers massive soil erosion, dumping raw dirt directly into the water. This cross-section shows a process called siltation. The eroded dirt settles at the bottom of the river, artificially raising the riverbed. The river permanently loses its capacity to hold water, guaranteeing an overflow during a heavy rain. The severity of this flood was the direct result of a landscape that had lost its capacity to buffer even common weather events. Compounding human exploitation stripped away the region's defense mechanisms, leaving communities exposed. When the water finally breached, the systemic failure was so rapid that citizens were forced to become their own first responders. Everyday heroism emerged from the chaos. Local day laborers like 25-year-old Shravan Kumar used small boats to rescue thousands of neighbors, even as their own homes were destroyed. A massive government response is now underway to stabilize the region, utilizing Indian Air Force helicopters to drop food packets and medicine to isolated villages. The administration is executing rapid triage, going as far as waiving mandatory postmortems to expedite 9 lakh rupee compensation payouts to grieving families. For the survivors, the reality is grim. Agricultural fields are ruined, livestock are gone, and families are spending their nights huddled on wooden planks under temporary tarps. Because the natural shock absorbers, the thick forests and deep riverbeds, are permanently gone, the threshold for future disasters is vastly lower. We cannot control the rain, but our removal of forests and the shallowing of riverbeds has changed how that rain behaves. Without those natural shock absorbers, the same environment that historically managed the monsoon now finds itself overwhelmed by it.